Hi, everybody. My name is Mark. I'm a 4-time tech founder and a 4-time national chess champion. Welcome to my series, Software Endgame, where we talk about where software is going to go in the next couple of decades. In the last 2 episodes, we spoke about how AI is going to take over the world, including the world of software dev. But today, we're going to be talking about, in the future of software, will we be using centralized service like Amazon Web Services to operate our systems? Or is there an opportunity to do something more decentralized, which we are going to go into? So when I first started writing software in the 90s, a long time ago, I used to write software that ran on one machine. And I used to play software like Solitaire, which ran on one machine. And so obviously, when the web started, there was the whole notion of distributed systems and web-based systems. And so I knew how to do like static web-based software, and I could build systems which were standalone. And in 1998, I was approached by British Telecom, who had started a game service called Wireplay initially. They changed the name later to Gameplay.com. And they wanted to build a chess system, and they heard that I was a chess player and I was a programmer. So they headhunted me for the role. I was slightly nervous because this whole idea of having a system where you would be playing people would be playing on different clients' applications through the internet. It was very novel to me, and I wasn't sure how that actually worked. But they explained to me that they had a platform where they could match people, and then my system would take over, and the people would actually play in a peer-to-peer fashion. Now, I'd never really heard of a server-based game at that stage. So that seems as good a way of doing it as anything. So I built a client application. In those days, I built it in Delphi, or Delphi, as the Americans say. And I had to figure out how to send messages between the clients, and to also tell the main service when the game was over, who had won, and that type of thing. So very naturally, I created this client, and basic game would be player 1 versus player 2. Playing chess, and they would just be sending messages from one client to the other. And the way that worked was I added a socket layer where I could send messages across the socket. And that way the players would get each other's moves, and that would be quite a happy case. But it wasn't as simple as that, because we also needed to have other players watching the game. So there could be unlimited spectators. There were other roles too, like coaches and administrators and that type of thing. And the question is, how could those people enter the game without having a server to update them about what was going on? Well, the way that we approached that was that I built a state management system where I chose one of the players. I think it was player 1. Who would then handle state between all the other participants. So if a new spectator arrived, then they would be given the updated state of the game. So they could arrive in the middle of the game, and they would be given all the moves, and then they could be watching live. So that worked very well. And the other problems would be, what happens if a player dropped out during the game? And the game maybe would be a 5 or 10 minute game. So they might drop out for a minute. Because of some kind of disconnection. And then you have to give them the opportunity of coming back in. So let's say in this example, player 1 would drop out, then player 2 would then pick up the state management system. So player 2 was the designated survivor in this series of nodes. And then player 2 would take on the task of updating spectators with information. If player 1 came back in time to carry on the game, then player 1 would be updated by player 2, and then player 1 would probably pick up the state management process as well. And in some cases, we also had to make allowances for what happens if player 1 and player 2 both dropped out, but the game wasn't over yet. They both still had like maybe a minute to come back in. So then spectator 1 would be the designated survivor to pick up the state management system. And so what this taught me at the time was it was possible to build quite a complex series of nodes around each game. And then we could have many games playing at the same time. And I didn't think about it at the time, but there was no cost, in terms of processing for the actual service to actually operate these games, because the processing happened on each person's machine. So that was my introduction to distributed computing. And my initial introduction obviously was a peer-to-peer introduction, which, even though it seemed normal to me at the time, later down the line, when I started writing my next game, which was a server-based game, I realized that the server could manage state and be the relay between the players and the participants. So in those days, so it was 98, 99, we basically built this client and it operated. Over the years, Amazon Web Services was born, and through Amazon Web Services, we don't even need to host our own servers at all. We are offering a server-based system. So we can operate on Amazon Web Services, Google Cloud, Microsoft Azure, and many others now. And that means we can build a centralized system where you could operate in one place and you can have one centralized source of truth, which sounds like a good thing. But the question is it really? So there are some downsides to running a centralized service on these cloud platforms. One of the obvious ones is cost, because if you have a peer-to-peer network, the costs are really kept to a minimal because all the processing happens on the clients and not on the server. And also, when you have a centralized system, you have to have every aspect of thinking about the application has to be written into the centralized system. And if you get a very, very complex software system, you have to find ways to operate that through a central point and think about it from a central point. And in many cases, you wouldn't want to do that. So I just want to give you an example of a decentralized internet system. So I'm sure most of you have seen the TV series, Silicon Valley, which is about a fictitious group of startup founders who operate a new service called Piper, which starts out as a new kind of messaging platform where they can compress and distribute content through the internet at a very, very high compression rate. And they get into all kinds of adventures, and it's very out of the ordinary. It seems very unrealistic. Although having lived in Silicon Valley, I can tell you that most of the stories that happen in the show actually do happen in real life in some way or the other. So as part of their journey, they pick up a very important customer, and they operate their services for this customer. They also host centrally their application on a cloud service that's offered to them by a very shady service provider. I think it was Huli in this case, and Huli's actually in competition with them. So what happens is Huli pulls the plug on them at some point, and now they have this really important customer that's paying them a fortune. It's going to make their whole company, but they suddenly realize that the whole system is switching off. So they head over to the customer to go hat in hand and explain to them everything's over, our servers are down. They walk in, and lo and behold, they speak to the customer, and they say, "Look, we are so sorry about the outage." And the customer says, "What outage? I've been using it in the last few minutes." And let me tell you what happened. So a few days earlier, one of the Piper software devs, he decided to hack the smart fridge in the house that they were living in because he needed some more firepower. And so he actually hacked into the firmware, and he put some of the Piper code on the fridge, and that boosted his processing of his system. And little unbeknownst to him, there was a massive upgrade of firmware across 10,000 fridges across the US, and all of them picked up on this hacked firmware. And suddenly, Piper was being distributed through fridges around the world, and the US mainly. And then suddenly, what that meant was they didn't need to have servers operated by Huli. They could actually operate off these devices. Now, obviously, it's questionable whether you're allowed to use other people's smart fridges or devices without asking them. But what it did do, it led to them understanding that the true value of Piper wasn't necessarily their compression algorithm. It was actually the fact that they had a distributed way to operate the internet. And so they actually pivoted their company and created the decentralized internet. I mean, experts look at this and say, oh, it's impossible. You wouldn't be able to hack into a smart fridge and utilize it. You certainly wouldn't be able to update all the firmware of all the fridges. But I think what's going to happen in the future of the world is that a lot of devices will become available for their processing, for their storage capabilities. And they will allow you to utilize them, maybe for some kind of fee. And so I think this notion is the truth. I think this is exactly what is going to happen, in my humble opinion. I want to also just talk about some other forms of distributed peer-to-peer systems. So One thing that's very topical right now is blockchain. It's in the news right now. The cryptocurrencies are running wild. It's a huge bull market. But without getting into too much technical detail, a blockchain really is it's made up of a series of hundreds of thousands or tens of thousands, maybe even hundreds of thousands of processing systems or computers, out there, and all of these connect and synchronize across the entire network. And they do this in a decentralized way, where there's no central point that has to update everything else. Every machine can interoperate through this entire network and participate in updating its database, which is its ledger, and then it helps in this participation. It helps to update all of the others as well. So you have a peer-to-peer network of processing, and so Bitcoin is a way of obviously building up this ledger and allowing transactions to take place on the ledger. But there are hundreds now, if not thousands, of new blockchains where you can do things like run smart contracts, which is a form of software that runs on different blockchains. You have blockchains that are very specific around certain tasks. And so what's actually happening is this proliferation of blockchains means that there are many new distributed platforms out there. And yet, if we want to use them, we have to interoperate with them. And so now what we're starting to see are new blockchains or other types of systems which can allow you to interoperate with blockchains or connect blockchains to real-world systems and cloud services, IoT devices, and that type of thing. So there's a big shift happening. And while it may seem that blockchain is very esoteric right now, it really is a huge step forward. And I really do believe that blockchain is going to be at the forefront of the whole revolution of a move towards decentralized computing, but it won't be the only thing. Another project that I wanted to point out is IPFS. So IPFS stands for the Interplanetary File System. And what that means is it's a platform for distributing content of some form, essentially files, but it could be video files, it could be documents, it could be any type of information that you want to store in a decentralized way. So the way to think about it is, in a more centralized fashion, you might store documents on a third-party service, or you might, if you're working with Amazon Web Services, you may store documents on S3. Again, it's a central system, but it's pretty well distributed. I mean, even those kind of systems are really well distributed around the world through CDNs. At quite high velocity. They are quite expensive though. With IPFS, how it works is it's a peer-to-peer network where your document gets fragmented into small chunks and then distributed across hundreds, thousands, millions of participating machines out there. And then if you want to view a document, it'll figure out the closest path to find those fragments of documents and reassemble them on your machine from all these other participating machines. And its promise is it's much cheaper than using something like S3, but also it can be faster, or as fast, but probably faster in certain territories as more centralized and distributed systems like S3. So I really just wanted in this session to talk to you about the difference between decentralized and centralized systems, the fact that we're moving towards distributed systems and have been, and that it's very likely that peer-to-peer type of systems which are decentralized are going to be the software of the future. It is very complex though, and it's not that easy for us humans to figure out how to connect to all these different machines, services, devices, IoT devices, AI systems, third-party cloud services. There are certain, there's functions like on S3. You have lambdas. You have all these many different systems out there that need to interoperate somehow. That interoperation layer is the key to the software of the future, and we need to be able to harness that, and we need to make it really easy to use. And that's why I believe that automation and the use of AI to help us to build the software and to manage it across this complex network is the key. And so that's the end of my talk, and I'm going to start the queue for anybody that wants to come ask questions or tell me more. So I'm bringing in Barry Hill, who is head of Engineering at Trixta, where I also work as CEO. Hey, Barry.
Hi. How's it
Good.
going? Cool. Yeah, decentralization. I remember us sort of discussing this quite early on in design because we knew that, well, that's a quality that we wanted in the software, and that, and for many reasons, we saw that all the things that you've mentioned now as being, as the case. But we still sort of need, so there's always like the client side aspect of that, which is still challenging. We know of some technology that's on the sort of horizon that would allow the current tech that we have on the server to run on the client. So we sort of, I guess, we're kind of holding out for that. I'm hoping that will then basically provide us with, both your server side stuff and client side stuff. What was that? Can you maybe give us some details on that? Is it called Lumen, right?
Yeah. So Trixta is built on Elixir, which runs on the Erlang VM. But Project Lumen allows you to take Elixir applications, and instead of running that on the Erlang VM, it converts that to LLVM, and LLVM can actually run directly on almost any device that supports any kind of device. But it also allows you to operate your software through WebAssembly, through a web browser, through a headless browser, and nowadays even outside of a browser, it's using WebAssembly. And do you see how? Do you see how that could maybe change the way that software is built in the future?
I do. It's like now we're currently building, with Trixta we're building server-side logic, and there is a way, we're currently designing the new IDE, and there's a way that we can sort of route everything through the server and basically take the sting out of the difficulty of building the front end. But we know that will come at a sort of a round trip cost, I suppose, and then obviously costs in the server side, and people then won't necessarily be able to work offline and stuff like that. So it would be good to be able to also take exactly the same. So if you learn how to basically build with it in one place, you could build with it on both sides. So I think that will definitely be key when it's available. Because then it sort of simplifies the bigger picture as well. Then things that need to be remote can be, and then things that need to be local can be. You don't have to make compromises as such.
Totally. And if you think about that notion of you could run the server on a server or somewhere else, or you can run that server or that piece of the server on the client. But it takes us towards the idea that you could take this larger service and it could be broken up into almost particles or separate elements. And some of them can be run on other machines, some of them can be run on your machine. If you're offline, you can run it all on your machine. But it's the same server. It's the same software running wherever it needs to run. And if you're offline, all you can't do is reach out to other external services at that moment, but you can still operate internally, and you wouldn't have to use JavaScript to write complex code.
Yeah, I got to experience a little bit of that with Meteor. There's a framework popular like a couple of years ago, or like a couple of years, more than that now. I'd say like 5 years ago. And that also had like a client side and then a server side and then a client side that almost mimicked the server side, and it sort of had its own local database, and it's kind of optimistically made changes to its local database to keep things snappy, and then would transmit that stuff to the server and sort of sync everything. And it was quite neat. It worked really nicely in terms of a sort of user experience. Everyone who's now used to using apps on their phones expect things to be instantaneous. They're not going to wait for a round trip. And I think that's one of the challenges for web in general, is just that sort of overhead, that slowdown that happens when you try to communicate over the line.
Yeah. Barry, if you drop off, feel free to come back in unless somebody else jumps in ahead of you.
Sure.
Yeah, in fact, what was interesting was when I was first conceptualizing the ideas around Trixta, in the very early period, I actually spent about a year looking at other systems, and we actually looked at Meteor as one potential way to build this. I gave up on that because I realized that Trixta needed to be an actor model based framework, and so, but it was really interesting to look at Meteor and some of the and Meteor maybe working with React in those days was what I was thinking about until I dropped the idea. But I do think there are things that will happen in the future that will make even round tripping, or some small amounts of round tripping, I think it'll get faster. I mean, with 6G coming after 5G, 5G hasn't fully landed, but I think as these things start to happen, I think there'll be acceleration. I think there'll be local processing for some things. I think they'll be distributed for some things, but maybe just small messages moving around at very quick latency is going to be useful in building out software. But I mean, what do you think about the idea of how do you define the software you want to build across all these distributed and disparate elements? What would make it easier to think about software, and how would different teams work together?
Well, I think the first thing to do is to sort of abstract what you're trying to do from how it's done, or how the individual different types of software devices work. So just try to distill and this is kind of, business language terms, that sort of thing, just like what it is you're trying to get out of the system, not so much, because then that frees you from what software actually needs to run on individual devices. And you can talk just in like a single, think of it as like a standard language that everyone talks. It obviously makes communication a lot easier. So that's, I think that a lot of languages you have today they're still kind of coupled to the technology that they run on. But some are, the ones that are successful are the ones that don't, right? The ones that are able to run in more places are generally the ones that are more successful. So yeah, I think that, with time, that language of logic will become clearer and clearer. And I think people will be able to talk that and not necessarily need to worry about the devices as such. Because I think we've had this is the information age, and obviously there's been growing pains, but I think now we're starting to see patterns form, whereas in the construction industry, they've had hundreds of years of practice, and now there's grooves in terms of like what works and what doesn't, and ways of describing things. And I think we're going to see that more and more with software. So hopefully when that happens, we'll be free of worrying about the actual devices that things are running on. We'll just be, we'll be talking about, okay, I want to achieve this now, that sort of thing.
Yeah, and I think that is the key. I think we won't ever get to a point where we can have more and more complex systems if we have to worry about the underlying hardware, or if we even have to worry that much about what software coding platform is being used. I mean, it's almost obvious that AI and automation are going to come in and take away the need to worry about the code itself, but also to take away the operating on top of these of these pieces of hardware. If you look at the blockchain now, you don't really have to worry about the hardware; it's taken care of. It just happens. Mm-hmm. And I think the same is going to be true of everything. And also, like you mentioned, you need a language to describe what it is that you want. But that language, in a way, could be more English oriented. It doesn't have to be code based. It could be talking to the AI, interacting with some kind of system.
Yeah, of course. Yeah. We are fortunate in that we picked Elixir as our language because there's, one of the features is metaprogramming. So we've got this almost air gap between the underlying sort of code that is actually generated and runs on whatever machinery from the actual language that we configure things in. So there's this sort of opportunity to fix things later if we find there's a problem in the design. So we don't need to disrupt the design. We still take what someone intended for the system to do and just fix the underlying steps and programs. I mean, it might sound like that's how most systems work, but it's not quite. That metaprogramming is very powerful, very useful. I'll come back again. I want to ask another question.
Okay, cool.
And there's someone else wants to join, of course.
Yeah, if anybody else wants to come join, ask a question, or just talk or argue, feel free to come on board. Otherwise, Barry, come back in.
Yeah, so just wanted to sort of talk a little bit about something that's like kind of current at the moment, when it was happened recently, and I think it's going to be one of those reasons why decentralization is going to be like the final answer. There was like the recent change in WhatsApp's privacy or their policy, whatever. I didn't actually know the details, but there was a sort of massive shock, and people were migrating to different providers, you know, like other like Signal, whatever, and that just goes to show, you know, people, you can sort of you'll adopt whatever software is sort of easiest for you to use and you're happy with, but they might change over time. So they might change their alignment or whatever it is that they're doing, or sort of it's something that you don't agree with, and then you're gonna keep moving. And there's only going to be, I would say, a number of jumps before people become wise and they say, well, listen, I'm just going to run my own system and own my own data, because obviously data is valuable. That's pretty much the main aim of the game for these big centralized sort of organizations, right? So rather you own your data and you can run your stuff locally, or just have a little bit more control over like your interaction with the rest of the world. So I think that's as people become more competent with technical things and being able to, I guess, have their own devices sort of represent them more so than going via another company. I think that'll probably happen, because I would definitely adopt a messaging app that was just a DApp, like something that's completely decentralized and has no like marketing going on. Because what I worry about is with I don't really mind so much about my like privacy as much as some other people do. But what I would find annoying is if, you've got companies that have access to a lot of information about you, and then they can kind of use that, not necessarily nefariously, but like to manipulate you for marketing purposes. So, just sort of maybe pester you or even get your personality wrong. And you just sort of like keep getting fed something that is, you just don't, it's kind of like 95% there, but not quite. And it could actually potentially change your personality over time. And I don't know if I'm really up for that.
Yeah, totally. I do think, that is a problem in the world. And I'm looking at the moment at security systems, and there's a company in Cape Town that's building a security platform. But what they do with their platform is they actually run processing on your premises. So they actually put a box down on everyone's premises, and then actually operates the cameras. And it does AI and all kinds of things, and it picks up, what's happening on the property. But then it can distribute information, but it only distributes small fragments of information as alerts happen. It doesn't take your personal information, people, their faces. It doesn't take it off site, which most security companies would do. They stream all the time, and I think that idea is going to become a central theme. That why should I run everything through this giant system of yours? Can't I run most of it on my own site and just share some information at the edges with you? I only need to reach out if I need stuff from the outside world, or if I need to push something to the outside world. And it's very efficient as well. It's cost efficiency as well, because if you want to move mass, just general AI, you want to move huge pieces of data across to a central system on Google Cloud or AWS or and then you have to move it across, then you have to work it there, then you have to bring back the information. But why not just do it in place? And I think the software of the future is going to have a lot of in-place processing. And in many cases, you won't even be in control of those other systems that are building your whole mesh of services that actually make up your software. So your software won't actually even be all your own software, but the pieces that are yours can stay yours, and the privacy around that information can actually stay private.
Cool. Yeah.
Cool. So I'll do one last call for anybody else to jump in the queue.
It would be great. It would be great if in the public space, if things were more transparent. So, I guess, using a multitude of decentralized systems to sort of get information to.
Okay. Very last. Do you want to come in and make a last comment to Barry? Okay, cool. Maybe you can do some closing remarks.
Yeah, just a final remark about how decentralization could also help with public sector stuff. Just sort of picking up anomalies and just making information a little bit more transparent. If everyone shares certain types of information about their environment and what's going on in whatever's public in your life that you are happy to distribute, that might just bring about a lot more sense to the world, and you can see that clearly, and everyone can kind of agree with it. Yeah, but I'm a bit of an idealist, so I know there's a way to go.
Me too.
From let's do it.
Exactly. What happens if you get two idealists in a room? That changes the world. Cool. Okay. Well, thanks, Barry. I'm going to close off. So I'll just so today we really just wanted to introduce the topic of decentralization and where the world could go. In next week, we'll probably dive a bit more deeply into what it means to be decentralized, how we can achieve it technically, and what key technologies that are coming through now are going to help us get there. Thanks very much. Next time, I'd like to see more people coming into the queue to ask questions, but I'll see everyone next week. Take care.